Okay, guys, this is the last topic that we're going to cover in the scope of the CS204 Advanced Programming course. Namely, we are going to deal with exceptions. Exceptions are very important because very often when we program on the right applications or websites or whatever, we should not assume that the users are going to be well educated. Very often we happen mistakes like this. You ask from the user to give his name or surname, but he gives his age. So basically you ask from him to give a string input, but he gives an integer, and vice versa. So those kind of mistakes happen very often, and not only with users, but they also happen with programmers. Very often your program abruptly finished, crashed, and when it crashed, you had got a message saying, okay, an exception occurred, let's say out of range exception. So basically what happened in this case is the following. You tried to access from an array of 10 elements something that from an array of 10 elements, you try to access something which is more than 10. Let's say you try to access the 15th, the 20th element, etc. Something outside of the scope of the array. So array has 10 elements, you try to access something with the index of the 11th, 15th, 20th element, etc. And the program crashes in those cases. Or sometimes this is what happens. You try to divide by 0. Okay, and it's not allowed, cannot be done. That's why the program crashes. Good programmers don't allow a program to crash. Rather, in a polite way, good programmers let users know that this kind of mistake happens, and please let's solve it in a way. Okay, so if the user is trying to divide by 0, maybe one of the solutions would be not to crash the program, of course, but to tell the users that, okay, maybe you should give another input which is not 0. Or if a user tries to access something which is more than the range of the array, the elements that the array has, the maximum index of the array, or something negative from the array, we maybe shouldn't stop the program. The program shouldn't crash. Rather, we should ask from the user in a polite way to try again or give a way to fix that mistake. So basically, what we are talking about are exceptions. Instead of program crashing, we just let the user know that a certain mistake happens and he or she should solve it, or maybe the programmer should solve it in a way, or maybe the users should solve it by giving a proper input. So let me share the screen. Okay. Let me write exceptions in C++. I need images about them. Okay. Most probably this one will do. So this is what we have here. Since we saw inheritance, this should be clear for now. We saw what exceptions are. Basically, as I told you, if a certain mistake happens, like division by 0, out of range from the arrays, etc., and many others, we don't stop the program. Rather, we throw an exception and try to catch it instead of crashing the program. Okay. For this reason, we have a class which is called exceptions, and it's part of the std namespace. It's part of the std namespace. Okay. And from this exception class, we have other classes which inherit this class, okay, like bad allocation, bad cast. So we have seen inheritance. Now we should know what this is. Then we have this logic failure class. From this one, those guys, domain error, length error, out of range error I was talking about. So this is logic failure. And then we have runtime errors, which also is inherited from the exception. And then we have overflow error, length error, underflow error, etc., which inherit from runtime errors. Okay, so these are exceptions. We are going to, maybe it's not clear right now. We will see an example. It should be much more clear. So how do we use exceptions? In the piece of code, in the part of code, in the block of code, where we suspect that a certain mistake might happen, like division by 0. Maybe we try to find the square root of a negative number, which is not doable in the domain of real numbers. Or maybe if we try to access an element of the array and we go outside of the range of the array, outside of the range that array has, instead of crashing the program, I said to you, we throw an exception. So we write this piece of code, the suspected piece of code, where a certain mistake might happen, which might crash the program. We write it in a block of codes, which we call the try, and then we try to catch the mistake that happened in that particular block. Okay, so let us see an example of that. Okay, how it works. Basically, you see this exception class. Well, this is a very simplified. We are going to see now an explained class which is called MyException, which is a very simplified class of the MyException class, which is part of std. Okay, so what do we have there? As private, we have a message, an array of messages, an array of characters, which is the message. So very often the program crashes, you get the message, out of range error, exception happened. And then you have message code like error code 307, out of range error, blah, blah, blah. So message code is an integer, okay, 307, 10, 20, whatever. You have seen those numbers. And then the message is basically kind of description of the error that happens. So these are the privates. In the private section, those are the private variables. In the public section, we have the constructor. We have function which is called what, and this actually exists in this exception class that I told you. But it's good if we code it, a very small portion of it, just to tell you the idea how it works. And then we have, so in the public section, we have the constructor, the parametric constructor. We have an array of characters, and we have the function what, which returns basically the message, and what code, which returns this message code. So let's see what the constructor is doing, the parametric constructor. Well, it takes an array of characters called MSG and an error code. In order to know where we are now, we just print that exception object created. And we set this message, the private variable, to be MSG, and the message code to be error code. Okay. Then the function what basically returns the message. Okay. Returns the message received, which is an array of character. And what code basically returns the message code, returns this guy. So this is all about the class MyException. Okay, now let's see another class, which is called integer division. So here basically, in the private section, we have two operands, operand 1, operand 2, and we have the result, which is kept as string. What this class is trying to do is divide operand 1 with operand 2. However, you know that we cannot divide by 0. That's why in the constructor, this is what we do. So this is the constructor of the class. It takes two operands, 1 and 2. It sets those operands 1 and 2 to be OP1, OP2, correspondingly. And now, this is an example of how we deal with exceptions. In the try block, so this is the try block. You write the keyword try, okay, and the block code comes then inside of it. And we use this try block in the place of code, at the place of code where we suspect that an exception might happen, a mistake, that an error that might crash the program, but we don't want the program to crash. So what do we do in this case? What might cause this program to crash? Well, apparently we want to divide operand 1 and operand 2, but the operand 2 is 0. If it's 0, the program will crash. So that's why we check this stuff. If operand 2 is equal to 0, what do we do? Well, this result, which was a string, we set it to be undefined. And then we throw an exception, okay? And when we throw it, we just throw an exception, which is an object of we just explained the class MyException. We threw an exception which as a message has this stuff, division by 0 in class. The error code is 10. And whenever we threw this, inside of the try block, even if we have other stuff after the exception is thrown, we don't continue with that. So when we throw an exception, we are finished with that block, okay? It's kind of return stuff, but we don't return, we just threw an exception. And after we threw it, we try to catch it. Catch it basically through an exception means an error happens, okay? In this case, the division by 0 happens, or was about to happen actually, but we don't let it happen. That's why we throw an exception, meaning that the normal flow of the program will not continue, okay? We'll stop it here, let's deal with that. And then we catch the exception, and here we just print that, how we deal with it. We just tell that, okay, this exception happened. So when we throw this, we are throwing an object of class MyException. Here we catch it, okay? And we just say that MyException in class e.what division by 0 in class. If we didn't throw this exception, we would have continued with the normal flow of the program. And what is the normal flow? Well, we divide operand 1 and operand 2. And if operand 2 was 0, it would have crashed. But here, if it's 0, basically we throw the exception. So we will not allow the crashing to happen. Otherwise, if it's not 0, very nice, we continue with the normal, the expected flow of the program. So we find the division between operand 1 and operand 2. We assign it to 10, and then we convert temp to string and assign it to the results. As simple as that. So this is the class integer division, okay? Inside of the constructor, basically with this try block, we check whether operand 2 is 0. If it's 0, we throw an exception. We don't let the division to happen, because if it happens, the program will crash. We do exceptions, so the program will not crash, so we will continue. So we catch that exception and print what happens, okay? We have also another function inside of the integer division class, which is getResult. It basically returns this result over here. Finally, before going to main, we have another, not class, we have a function which is called divide. It divides A and B. It takes two parameters, A and B, and we want to divide A and B, but of course, if B is 0, it cannot happen. That's why we check if B is 0, the function throws an exception. And when the function throws an exception, we don't return anything, okay? We just threw an exception, the execution of the function stops there. Whenever we throw an exception, we cannot continue with anything else without dealing with this exception. So when we throw an exception, we must catch the exception and deal with it, okay? And when we throw an exception over here, basically we don't continue with dividing A and B, okay? Because it's just like it was the case here. When I throw an exception of exception of the class MyException, okay, I don't continue with this part over here, okay? And similarly in this fashion here, when I throw in exceptions, I don't continue with dividing A and B, okay? So basically, I don't return the double value I'm expecting because I'm throwing an exception, okay? Now let's see in main how we deal with this stuff. So in main, we have two doubles, I and J. We ask the user to give data. User gives data over here up until we press CTRL+Z. And here in this try block, there's a couple of places where an exception might be thrown or an error might happen, okay? That's why we put this suspicious code or piece of code where an exception might happen, when the program might crash into a try block. And here we have different type of exceptions that might happen. And here previously we saw only one catch, but we can have as many catches as we want. So, and the interesting part is that whenever we throw, let's say, here we threw an exception of class MyException, but sometimes you want to throw an exception of other type, like here we threw I, and I is of double, okay? So we try to catch them according to the data type that is being thrown, okay? So if I'm throwing an exception of class MyException, I should catch it in MyException. If I throw a double, I should catch it in the double section. If I throw an array of characters, I should catch it over here. If I throw an integer, I should catch it over here. Finally, always we should put this in the end. If we throw something which is a data type, which is not of any of these guys, then if we put in the end this catch block, is going to catch every exception. Okay. Now let's run the code first. Let's see what the code, what the while loop is doing, and we'll run the codes with, and we'll do some changes with the code. So let's see how exceptions happen. So I give I and j, and then I'm calling the divide function. Okay. But remember, the divide functions try to divide a and b. And if b is 0, I don't return the a and b value, which I want to print, a divided by b value. I just throw an exception. So if I give for j 0, basically I'm going to throw the exception, which is called division by 0. Okay. So first of all, let's do something which doesn't throw an exception. So if I give for a positive numbers, so if I give j which is not 0, okay, I'm going to divide it. I'm going to print the output. Furthermore, if I is smaller than 0, then I throw I, but I is of type double. Okay. Otherwise, if I is not smaller than 0, then I find the square root of I. So why do I throw I over here? Well, I throw it because if I try to find the square root of a negative number, it doesn't exist. Okay, so logically the program should crash. Okay, so here I prevent it from crashing. So there are two exceptions that might happen in this try loop, in this try block. I'm sorry. One is from the divide functions, which is if we try to divide by 0. This is the exception. MyException is going to be thrown. So the data type that is going to be thrown is MyException. And another one is if I is smaller than 0, then I'm going to throw I, and I is of type double. Okay. So let me run the code first. Let's give values which don't throw an exception. And later on, we'll give values that give an exception. So for I, I'm giving 5, which is positive, 2, which is not 0. Then I'm printing 5 divided by 2 from the divide function, and it returns 5 by 2, it's 2.5. Furthermore, is I smaller than 0? No. Then I just go with the square root of 5, and the square root of 5 is this one, 2.23. So far, so good. Now, let's give another input. I'm giving 5 and 0. So when I call the divide function, I'm trying to divide 5 and 0. It will not happen. What is happening then? When I try to divide 5 and 0, since b is 0, okay, in divide, I just throw an exception which takes as parameter this stuff, division by 0 and 10. So basically I'm calling the constructor. And if you remember in the constructor, we printed this stuff, the constructor of the MyException class. Exception object created. So I printed here, exception object created. And then after I created the exception object here, I threw it. And when I threw it over here, I don't continue with this piece of code. I just threw an exception. I don't continue anymore. And now I have to deal with this exception. And what did I throw over here? Well, I throw my exception, an object of that stuff. So I should catch exactly the same class. This is important. So here, if I try to catch, I'm actually catching, the first catch block is about it. So I'm catching it. And if I catch it, this is going to be true, basically. This is going to be executed. So I print MyException exception. Okay, the type of the exception is MyException. Then I'm printing what and the code. So MyException exception. What the message is division by 0, the code is 10. Okay, because this is how I gave the parameters for the constructor, parametric constructor of the MyException class. My division by 0 and the code is 10. Okay, we saw it. What happens if j is 0? Now let's see the case when I is 0. In that case, I'm throwing I. Let's see what's going to happen. So I'm running it again. So I'm giving -5 and 2. -5 divided by 2 is -2.5. So this part is going to be executed, no problem. No exception is thrown. Now I continue with this if. Is I smaller than 0? Yes. Then I'm throwing I. And I is of type what? Double. So when I throw I try to catch it, to deal with it. So I'm throwing a double. So this is not going to catch it. Well, this is going to catch it. That's why I'm going to print, you're trying to get the square root of num. Okay. You're trying to get the square root of -5. Okay. Now, let's do some experimentation over here. If instead of throwing double, what if I cast it into integer? So right now this I is not double, it's integer. Let's see what is going to happen. And I'll give I to be smaller than 0. So I want to throw an exception, which is integer. Let's see what's happening. Okay, so I'm giving -5 and 2, let's say. Well, I'm printing -5 divided by 2 is -2.5. Then I have integer exception -5. Why did it happen? Well, because when I throw I is not double now. I casted it to be integer for this purpose. So I threw an integer, and I should exactly catch an integer. So here I catch my exception. It's not going to work. Here I catch double. No. Here I catch an array of characters. No. Here I catch integer. Well, I throw an integer. I catch an integer, and I'm printing integer exception. So when I threw an exception of a certain data type, it must be caught from exactly the same data type. Otherwise, it's not going to work. So if I throw an integer, I cannot catch it with double. Okay. If I throw a double, I cannot catch it with integer. If I throw an integer, even I cannot catch it with long integer. I must catch it with an integer. Okay. Let's do something else now. Instead of throwing I, when I is smaller than 0, so when I give a negative number for I, let's throw rtrim. So you might think that rtrim is a string, but actually it's not a string. It's an array of characters. So that's why. Let me run the code, and let's see what's going to happen over here. Okay, I'm giving -5, so I is negative and 2. Well, char star exception, rtrim happened. So basically, when I throw rtrim, I'm throwing not a string, I'm throwing an array of characters. Okay, so when I throw it, it's not going to be caught here or here, but it's going to be caught over here. That's why I'm printing char star exception happened. Okay, now let's make a string from this guy. And one way how to do it is the following: cast. So I'm casting this guy to string. Okay, so I throw it now. When I threw it, now check this stuff. I'm throwing a string, but I don't have any string here to catch it. So I have MyException double. This is not a string, so this is not going to catch it. Integer. Let's see whether this is going to catch it. Okay, so I'm running the program now. Enter data -5 and 2. I divide them and I catch it into the generic exception. Okay. Why? Because I didn't have any string. That's why I catch it over there. Okay. So if instead of integer, if I had here, let's say, or maybe let's not touch this guy. Let's leave it like that. If I had a string catch block, string, let's call it str, then I would have written here string exception, and I'm just printing str. Okay. So let me run the code now. Again, I'm throwing rtrim, which is an array of characters, but I'm converting it to string, casting it to string. So when I throw it now, okay, I'm giving -5 to string exception rtrim because I catch it over here. That's why it's a good programming practice in the end to just write this generic exception which catches exceptions of any data type. Now, before finishing, and this is maybe the last trick or stuff that you're going to learn in CS204, let's do some connection between inheritance and exceptions. So you saw in the previous class that strings, that in inheritance, you can assign objects of the derived classes to the base class. So for this reason, let's go to this class, which is MyException. And remember, so remember this picture. So we have the exception class, and from that we just inherit the other classes. Maybe, I don't know. Let's inherit the class, which is, I'm going to call now class. You can give it any name. Let me call it inherited exception. Okay, so this is the class name, and it's going to inherit publicly this class, exception, MyException. Okay. So let's see what are we going to do. But now, if you remember those private data, if we try to access here, let's say if I write message, you know, this is something strange, or because it says declaration has no storage class, or so it's not declared. But if I make it protected over here, okay, then I don't have this error. Shouldn't have this error anymore. I can just maybe print it, or I don't know. Which I shouldn't have it anymore because let me write the constructor then, because protected means that the derived classes can see it, but the others cannot see it. So let me write the constructor for this guy, which is similar to this one. Not this much similar. I just wanted this one. Okay, never mind. Okay. Okay, so this is my constructor. And here in my constructor, I don't know, let me write what? That the message, this message, the protected one, is equal to, maybe I should just inherited exception, something like that. Okay. And the code is whatever. Maybe message code is equal to error code. Maybe the message should be something like this: is MSG plus, maybe I should, okay, never mind. I don't want to deal with this stuff. I'm not dealing with strings. Okay. So I should have here error code. Okay. What do the problem? Okay, so I should declare default constructor over here, which is not doing anything. Let's keep it that way. And I don't have any problem right now. I should put semicolon here since I declared the class. Okay, so I have inherited exception also. Okay. Now, let's go to our piece of code over here. And here, let me throw inherited exception. And now let me give something. Maybe I say here rtrim, blah, blah. And I give the error code maybe 404. Is this okay? Why it's not accessible? Okay, because it should be public. By default, it's private. Okay, now it should be accessible. Okay, so now I threw an exception, okay? And inherited exception publicly inherits my exception. And when I get this problem, when I smaller than 0, I throw inherited exception. So let's see what I'm going to do with that. Let me write the catch block for that guy. Okay, here I'm going to write inherited exception. Let me call it E. And here, instead of my exception, I'll just tell that here I'm dealing with inherited exception in cout. Okay, the rest is fine. Now, so when I smaller than 0, just through the inherited exception. Let's see what I'm going to get. I'm running the code. So -5 and 2, let's say. Okay, I divide -5 and 2. It's -2, and then I catch it, inherited exception, code 404. Now, let me do some changes over here. Instead of, so I told you, when I throw an exception, I must catch it with the data type that I throw. But there is a problem here. So let's take the inherited exception and put it maybe after my exception. Okay. And remember, my exception is the base class, and inherited exception is the derived class. So I'm running the code again. And don't forget, I'm throwing an inherited exception over here. And I already catched the inherited exception. But let's see what's going on over here now. So I'm throwing again. I'm going to throw an inherited exception. I give -5 and 2. But I'm catching my exception. Okay. So I'm executing basically this one. When I throw it, I'm catching it with this one. Why it is the case? Well, that's because of polymorphism. That's because we can assign derived class to the base class. Okay. Just because we can do that assignment, when we deal with catch blocks, if we write a base class first, basically it's going to catch all of derived classes, of course, in the base class as well. That's why when you're dealing with exceptions, always first, if there are classes that are inherited from each other, always first write the catch blocks related to children, to the derived classes, and then after them, you write the base classes, because you want to be in the beginning as precise as possible. And as catch blocks continue downwards, you can be as general as possible. And always don't forget, the last catch block should be this one, okay, which is the generic exception, which accepts all, which catches all of data types, okay? So this is the only exception with exceptions, okay? So when you throw a data type, you must catch the exact data type, except when you're dealing with inheritance. In inheritance, it might happen that the father class, the base class, can catch its derived classes or subclasses or children or grandchildren classes, okay? In that case, you should put the derived classes, the subclasses first, and later on you put this father class or the base class. Well, guys, this is all about exceptions. Yeah, we have like this example also. So you remember the integer division class, which in its constructor tries to divide operand 1 and 2. So basically, we have this D1, in D1, an object called D1 of integer division. Here we try to divide 2 and 0. But if you remember the integer division class, we have this try block. If operand 2 is 0, the result will be undefined, and we'll catch it and we'll say that, okay, problem, division by 0 happens. Furthermore, we have another object of the class in integer division, which is called D2. There we try to divide 4 and 2, which is not a problem. That's why when you go outside of this while loop, we go outside of it, you're going to see those two cases. In the first case, we have exception. In the second one, we don't have an exception. So basically, if I don't want to have an exception, I'll just give Control Z. so to go outside. And then in D1, exception object created, because when I try to divide by 0, I don't do it. I check whether operand 2 is 0. And if it's 0, I throw an exception. And when I throw an exception, I call the copy constructor to create an object of my exception class. And in the copy, if you remember, not copy constructor, the constructor, the parametric constructor, and the parametric constructor, I wrote exception object created. Then I print the error that happens, okay? So in the constructor of that guy, of my exception class, I just print this stuff, that exception object was created. And here when I throw this exception, when I catch it, I just print that my exception in class division by 0 class, okay? So my exception in class division by 0 in class, okay? And of course, when I want to print D1 in main, so D1 result is by calling the get result member function from integer division, it will be undefined, okay? You remember we set it to be undefined. We try to divide by 0, okay? So result is undefined. Otherwise, if operand 2 is not 0, everything works fine. So we divide 4 and 2. And in that case, D2 result is 4 divided by 2 is 2. Okay, guys. So this is all about exceptions. And this is all about CS204. And this is our last class, basically. It was my pleasure to be your TA. I wish you all the best in your careers, in your life also, in finance, of course. And our friendship does not end here. As a matter of fact, I hope it will continue furthermore. You can feel free to contact me about any problems, any advices you might want from your career, issues you might have with coding, etc. Not only finance. So you know my email, or you know my office. You can come and visit me for any problem or any issue you might want, or advice, or whatever. Again, I wish you all the best. Stay healthy. All the best in your career, in your life. And good luck then. Okay. See you guys. Good luck in the exams. Take care of yourselves. Bye.